My name is Josh Saul. I'm a senior technical marketing engineer with Apstra, and now I'm going to give you a quick demonstration of how to visualize traffic trends for optimal network performance. So network operators are always trying to better understand how traffic is actually flowing through the network. With virtual networks and virtual machines, we know that traffic flows can be hard to identify or locate. An application that consumes a large amount of network bandwidth might be in one area of the network one day and a totally different area of the network the next. So we wanted to give AOS users the ability to overlay traffic statistics on the network diagram itself with nice indicators and call out interfaces that may be reaching a point of saturation. So this is all visual. Obviously, let's just jump straight into the demonstration. Okay, I'm going to use a different topology for this. I'm going to use something that is much, much bigger. So I have this blueprint Nutstorp, which sounds to me like an IKEA product. And I'm going to jump right in and take a look at the dashboard here. But really what I want to do is I want to go straight to this active view, okay? And the active view is the topology of the network that is overlaid with relevant information. So here is my topology, and I can show the links if you want to see that sort of stuff. But this functionality is actually revealed through we have the ability to layer on information. And what I want to layer on is what we call traffic heat. So this is real-time information that's in that data store that is related to all these devices, and it is presented to me in a visual color-coded format. So you can see that there is a legend up here on the upper right-hand side, 0 to 20%, 21 to 40%, and so on. So from green to amber, this shows how much a particular device or interface is loaded. And it's percent-based, so I don't actually have to code it for 4 gigs of a 40 gig interface. AOS can obviously tell the difference between a 40 gig interface, a 10 gig interface, a 100 gig interface. And I just want to look at percentages. I just want to know how loaded some of these devices are. And everything in AOS in the user interface you can drill into. First, let me just show you that in addition to the color coordination, we have these indicators for anomalies. So I have some high water mark, and I want to know if I'm above the high water mark for a certain amount of time. And that's what these little red exclamation points are. But let's drill into a device. Let's look at spine 1. And you can see that spine 1 has a certain number of interfaces connected to all the leaf switches. Let's jump back to the leaf view for 1 second. And let's go to a leaf and look at how the servers are connected. So you can see how much traffic is on any particular server link at any point in time. And in fact, if you hover over them, clicked on the wrong thing. If you hover over these interfaces, you get real-time view of essentially the show interface command, right? It's not just transmit and receive. It's your unicast, broadcast, multicast, FCS errors, framing errors, CRC errors, runts, all that stuff is presented here. So what a standard, what a network operator would be looking at is all presented, and this is in real time. So this is going to get updated, every 15 seconds based on, you just sort of watching it. And what's important to show you here is that I can trace out the path. I can look at, okay, from this particular server, I want a headroom view. I want to look at from this server to another server on the other side of the fabric. So let's pick a neighbor somewhere else on the fabric, and I'll scroll down to this one. And now AOS, based on the graph model in real time, builds out the entire clause fabric, right, with all of the ECMP paths. So right now I only have 2 spines, but imagine if I had 8 spines and 50 leaves. This diagram would look pretty substantial and pretty interesting. And the interfaces are, again, color-coded and are showing how much traffic is going through them. So I can immediately drill into what's hot in my network and identify things like, a server that's doing a backup while the application is still running. Now, this is really important because operators, probably 10, 15 times a week, you're asked by the server team, well, server A to server B, there's some sort of communication issue. The network is down, right, as far as they're concerned. And you can quickly determine why is that person saying that packets can't get through the network. I've already validated that L3 fabric is up, my L2 services are up, so on. But maybe I have too much contention for some of these links. And here it's all presented visually. So really quickly, you can say from server A to server B, show me all available paths. And this is based on intent. So if I add a new switch, if I add a new spine, immediately that will appear in the diagram. If I put a device into a drain state or into maintenance mode, it's immediately removed because AOS knows that this device is no longer forwarding. It's no longer part of the routing domain. So again, this is really tied back to intent. These models are built based on that initial graph design and all the subsequent changes. So in addition to viewing this in real time, we also have a time series view. So someone says to you, well, at this particular time slice every single day, the application fails. So I want to go and change it to time series. And now I get the same view on the bottom, but I can select my time slice on the top. So here I'm collecting all of this data over 30 days, and I can pick which day I want. So I can just dial it into a particular day. And let's go here. And then I say, well, which hour do I want to look at? And then with this toggle, I can go back in time and say, okay, on this particular point in time, the network was doing this from point A to point B. And this is just like, if you want to figure out exactly where the bottlenecks are, given the, fully redundant and equal cost, multipathing that we have in our networks, becomes really challenging. You have to go to every single device and do show interface and BGP neighbor and make sure they were up and all that. This is all done automatically on the fly in real time with AOS. And again, now we have this time series functionality and the visual overlays that allow you to see it. So just to recap that functionality, the telemetry views are created from intent. So you don't have to do anything. They're always there. And the traffic statistics are always, they're always being gathered by devices, regardless of which vendor or which show interface command or what sort of, command you have to run in order to get that. The traffic is normalized. The units are all exactly the same, even though some vendors use, still kilobits per second and others are using gigabits. We can put that traffic onto any of the network views that we have. And that there are a lot of views that I haven't shown you. And that same heat layer can be applied to any of those views. And again, we can apply this from any node to any other node in the system. So we also have the ability to track where VMs are located. And you could very easily say, I want to know from this virtual machine on this virtual overlay across my network, what are the available paths and how much traffic is being eaten up on the physical network. Now that's really powerful. That's visibility of the virtual machines and all of the traffic overlaid at the same time. So I think this feature is really cool. I get pretty excited about it. Sorry, there's a question.
In that real-time view, you were saying that was polling every 15 seconds?
Yeah, actually on this view, it's
just when you get down to the end-to-end view, I assume, not like the whole network every 15 seconds.
The traffic is coming off of the devices every 10 seconds. The user interface is refreshing the UI, the web browser, every 30 seconds. You can actually dial that down. But no, we are gathering the traffic on every single interface every 10 seconds.
Good grief.
Yeah, does that sound pretty crazy?
Yes, that does sound pretty crazy.
It took a lot of engineering to get this to scale to hundreds and thousands of network devices. But indeed, we have some of the largest data centers in the world under AOS control, and they are running this without a problem.
Wow, okay.
And we are following our vendors who we work with closely to do right thing. Streaming telemetry is coming. When it's implemented by everybody and properly, we might move to more real-time data and more optimized. As of now, show counter, show interfaces is a common and most optimized way.
And just one more point, George said that this is intent-driven, and part of the intent is your choice of where do you want to collect this data from. So you can say collect it from the whole network, or you can use a query and say, well, connect it from, only lives in data center west because that's what I care about right now. So there is a way for you to choose the subset of telemetry to be collected. So it's not like all of it all the time if you don't want it.
Yeah, I mean, historically, devices have been so poorly written that trying to get stats every 10 seconds has been a nightmare for them. But it's been getting better over time as the CPUs have got better, the streaming telemetry is where I'd like stuff to get to.
Yes.
So we're not reliant on SLMP, things like that. So.
Seems still a little bit scary. Tens of thousands of devices every 10 seconds, a little bit scary. So
And,
Yeah,
and also that many TCP sessions, if you're actually doing it, for actually getting open TCP sessions is fun too.
Yeah, so just keep in mind that a lot of this is actually made possible by the agent, right? So when you have the on-box agent, the agent can sit there and can check all these interfaces. It's sitting right on top of the box. It can check in real time. And it only really needs to send the differentials back to the AOS server. If there's no change, it says no change, no change, no change. And it's an optimized binary protocol from the agent back to the server. So it's not like we actually need to create these TCP sessions in order to gather the information from every device every 10 seconds. We do have to do that for some of the off-box design scenarios, but with the on-box agent, it's speedy, it's fast.
and only differentiate data. So will be, I assume, will be very small amount of data. So bandwidth point of view also will not be a problem.
Yes,
that's right. And just with checking things to check for telemetry, the local agent actually knows what it's looking for. So it doesn't have to like send it back to the AOS server to parse things. It says, I have 5 BGP neighbors. These are the ASNs. These are the IP addresses. No change, no change, no change, versus saying show IP BGP sum and just streaming that back and forth. Yeah, obviously that's going to put a lot of traffic on the network. So we don't want to do that. We have this optimized method for doing it with the agents.